So we're going to continue our work in topic 6.9, which was integration, pretty much everything we wanted to know. And we're going to look at some integrals of trig functions. So we already know the integrals of these 6 trig functions. Those ones are very familiar. We get them because we're basically reversing the derivatives. But there's some other basic trig integrals that we should know. So we're going to start by finding both tangent and secant so you can believe what is written down here, and you can know that you can recreate these if you don't have them memorized. So we're going to just look through example 12. I'm going to start by rewriting tangent as sine x over cosine x dx. And now I'm going to use u substitution. So I'm going to use my denominator here as the u. So u is equal to cosine x, which means that du is equal to negative sine x dx, meaning that I need to multiply top and bottom by -1. So let's go ahead and do that. I keep a -1 technically in the denominator, though it doesn't really matter. And then this one gets shoved inside. And we've got sine x should be light blue because that's my du. And then we are over cosine x, and then the dx is the light blue. So I have all the parts I need to now do my substitution. I'm just going to make this a negative in front. So the integral of 1 over u du. And we know when we integrate 1 over u, we end up with negative natural log absolute value of u plus c. And then I'm going to substitute in, so we get negative natural log absolute value. My u is the cosine x, and then plus c. So the integral of tangent is negative natural log absolute value of cosine x plus c. You technically don't have to go through those steps. You can just memorize that. But if you don't get it memorized, there's a way to actually recreate that. So the next thing we're going to do is a little bit more complicated. I am going to use a u substitution again. My u is going to be a little bit weird though. So in order to prove this one, I need more than just secant there. Okay, so I'm going to multiply by something really weird. I'm going to multiply by a 1, but it's going to be a really weird looking 1. I'm going to multiply by secant x plus tangent x over secant x plus tangent x, which is just a weird looking 1. Okay. So what that means is if I distribute this secant in up on the top, I have secant squared x plus secant x tangent x all over secant x plus tangent x dx. I am going to use my denominator as the u. So u is going to be secant x tangent x. So that means du, I am going to be using the product rule. So we're going to do du. And then I know I have my red and I have my green, right? So the derivative of the red is secant x tangent x. Okay, keep the green the way it is, right? That did not turn out what it was supposed to be doing. Derivative of, oh, I see why. Derivative of secant, or the derivative of, no, we're doing fine. The secant tangent. Oh, I messed up. Look at what I did, you guys. I wrote this wrong. Totally wrote it wrong. It was secant x plus tangent x, okay? So that makes the derivative a whole lot nicer, no product rule. Derivative of secant x is secant x tangent x. And the derivative of tangent x is secant squared x. And what do you know? That's exactly what I have here, and then I have to throw the dx after it. So that just became so much easier. All right, so we're integrating. I'm doing my u sub. So u goes in for the orange, and then for the blue, I am putting in the du plus 1 on top. So when I integrate that, I get the natural log, the absolute value of u plus c. And then I'm going to go ahead and substitute in for my u the secant x plus tangent x. So anytime I see secant, I know when I integrate it, I get the natural log of secant x plus tangent x plus c. And you can see that we have them summarized right here, so you can actually use them to evaluate now.